Okay, this is the P3 paper from June 2024. It's question number 1, and this is a functions and graphs question. In particular, as you can see, we're going to be looking at modulus functions. So let's have a look at part A, which says we've got this function, fx equals 2 modulus x minus 5 plus 10, and it asks us to find the coordinates of point P here, which clearly is the minimum value on the graph. So really straightforward with this one. Fx is equal to 2 modulus x minus 5 plus 10, and we can see that the modulus part, this part here, well, the smallest value that can be, if it's a modulus, the smallest value that can be is 0. So if we've got 0 add 10, the minimum value is going to be 10. Where is that going to occur? That's going to occur when this works out to be equal to 0, and this will work out to be 0 when x is equal to 5. So let's just write that for the examiner. So P is the minimum point. Minimum fx occurs when 2 modulus x minus 5 is equal to 0. Min fx will be 10. And if 2 modulus x minus 5 equals 0, x is equal to 5. So to clarify, P is the point 5, 10. Very straightforward for part A then. Part B, use algebra to solve the inequality. When is 2 modulus x minus 5 plus 10, when is it greater than 6x? So I'm just going to use the graph to help me here. If I've got a gradient of 6x, well, I know the gradient of this one is 2. So I know that that's a gradient of 2. If I've got a gradient of 6, then it's going to be steeper than the 2. That doesn't need to be perfectly accurate. That's good enough to be my y equals 6x. And what I can see from that is that there is just one point of intersection. And once I find that point of intersection, when x is greater than this value, then the 6x will always be, when it's less than that value, apologies. We're looking for when it's less. So to the left-hand side here, when x is less than whatever this value is, then the 6x will always be less than the function. Okay, so let's find where it actually intersects then. And again, I can keep looking at this graph here. When I'm looking at my function then, this one has a positive gradient and this one has a negative gradient. And the intersection is going to occur when 6x hits the negative part of the graph, the negative gradient. So putting all that together then for part B, we can say trying to solve 2 modulus x minus 5 plus 10 is greater than 6x. Let's find the critical value. That's what it's called when we have inequalities and we want to find specific values. The critical value, it was where 2 modulus x minus 5 plus 10 equals 6x, and we only need to consider the negative. In fact, let's say that only need to consider, there's only one point, we only need to consider minus 2 x minus 5 plus 10 is equal to 6x. So that's going to make our work much quicker. Let's tidy that up. That's minus 2x plus 10 equals 6x, and that rearranges to 8x equals 20 to x equals 5 over 2. So what we just said from the graph is we can tell that we want x to be, the other way around, done it twice, x to be less than 5 over 2 for the criteria to hold. Okay, that's part A and part B done. Part C, find where the point P, which we know, is mapped if we start off with y equals fx and it's transformed with 3fx minus 2. Yeah, again, that should be hopefully relatively straightforward within our transformations. So y equals 3 lots of fx minus 2. When I'm looking at this, then I'm going to do f of x minus 2 first, then I'll multiply by 3 afterwards. So for point P, which was 510, f of x minus 2, so that's a translation, isn't it? That's 2 units to the right, means that P will become 710 from 510. It moves 2 units to the right, and then 3 lots of fx minus 2, that's going to be a stretch, scale factor 3, parallel to the y-axis. So instead of having 710 now, we're going to have 730. Let's see how many marks that's worth. I don't think, yeah, it's only worth 2 marks, so I don't think I need to give any more detail than that, especially as I've explained it to you on the video. So new point is 730, just to make it really clear to the examiner. And that's question number 1 all done. Hopefully that all makes sense to everybody.